or you're kind of screwed. Seeing how many people showed up, guess I'm not screwed. Appreciate that. So my name is Kerim Satirli. I used to be a former operations engineer. Now I work at HashiCorp as a developer advocate. I get to teach people about best practices in infrastructure, security management, secrets management, and networking. Basically get to tell people what they should be doing, but I don't get paged at night, which is great. It's kind of like a platform team. I'm at K Satirli pretty much everywhere. So if you have thoughts or concerns about this presentation, definitely let me know. Also happy to talk about whiskey and chocolate cakes. Also loved your chocolate cake during lunch. Somebody recommended that to me. Thank you so much. Huge fan already. So I know it's late. Y'all had food. We're all tired. Lunch was great. I want to get a quick understanding of who you are. So raise your hand if you've been in IT for more than a year. All right, beautiful. This is great. No, keep the hand up. More than 5 years? All right. How about 10? 20? Man, all right, this is perfect. So if you've been in IT for that long, we're going to switch a few slides up. Sometimes DevOps Days has very entry-level audience, sometimes it doesn't. It was going to be a coin toss. Should have worked with Matt from the betting side to make a bet here. So no matter if you call yourself DevOps engineer or just DevOps, SRE, platform engineer, whatever title you choose and make look great on LinkedIn and wherever else you put it, we all generally find ourselves in a situation where our skills get tested, right? New technologies come out all the time. Most new technologies take an existing concept and try to repackage it in a way that makes sense for the new thing, but maybe doesn't resonate as much. If you work with any of the cloud providers, networking in AWS versus Azure versus GCP, different terminology, pretty much the same headaches. It's great. So when we look at skills in IT, and we're looking at technical skills, we're not looking at the people skills because that's going to be the burnout session later. We're going to look at 5 categories that we can split things into. Primarily, infrastructure, obviously. It was in the title, but infrastructure is so much more. It's, in our case, we need to talk about packaging. Hannah talked about using Docker, deploying to Kubernetes. Other speakers did too. Getting to that unit that you can deploy is, of course, work. And let's be honest, if you're in a project for a couple months, eventually somebody goes like, well, we should add some security to this. It's never the first thing. We all know this. If you go through the change logs for popular IAC tools, Terraform, Ansible, Chef, Puppet, security features were not a day one thing. Because in the Wild West, we optimize for shipping shit fast and not so much for security. That's okay. Sometimes that's how you build a proof of concept. Sometimes you just want to hit the ground running. And with a lot of security, you would just hit the ground. Personally, I know security is hard. I love it. I love working on it. I love making it frictionless. But honestly, SpaceX putting rockets in space sometimes seems easier than getting a team onboarded to actually sane secrets principles. And then, of course, networking, the age-old crux. How do we get stuff from A to B, and how do we get the right stuff from A to B? I prefer my application to be world accessible. I don't like my service to be world accessible. Finally, orchestration. We have an application, we have network, software-defined, hardware-defined, aka plugged-in cables. We somehow still need to run everything. And these things are hard. These 5 skills cover a large part of what ops engineers, and we're using that as a stand-in for every other title that you can have on your LinkedIn, need to know outside of the human aspect. The human aspect is the hardest part. This is easy. By the end of this session, you will have enough ideas to push your career forward increase your market value. I was told not to say that because people should not focus on the value they can get from their company. And I will tell you, I disagree. Most of us work because we like getting paid, because it allows us to do other fun stuff. If you're looking for ways to waste money, DJI just released a beautiful new drone. It's only 15,000 euros. That's why we work in IT, right? So, very large range of things, and cool. Animations, always good. Very large range of things you should know about to become a better engineer. And if you self-identify as a front-end engineer, back-end engineer, anything but an operations engineer, these are still things that knowing about will push your career forward. If anything, you could switch to ops engineering and be paged at 3 in the morning. Get sweet 200% salary for that hour. So if we zoom in on them, always put more than 7 words on a slide. My slides are usually very barren. So I grabbed the scariest things that I could think of. My personal favorites on here. DNS and why it always fails. In the orchestration category, hardware support. No, we tested this, and it can definitely handle that many requests per second. Is not something you will ever find in the documentation for a hardware security module, but at least they're expensive. Encryption at rest, if you've had to deal with that, super fun. Pretty much covers all the other areas as well, because you have to think about literally everything that goes in. And of course, when you work cross-functional or cross-team, how to bake security into your containers before they become containers. There is I think the technical term is a shitload of things you need to know. Piece of cake. Super, super easy. Just a handful of skills. If you put all of these on your LinkedIn printed out is probably going to be 23 pages. But you're going to have so many jobs. It's beautiful. So, title of this presentation is Up-Level Your Skills with a Compute Cluster. So in the next 18, 19 minutes, what I want to talk about is 5 learning paths that you can work on in your free time, which obviously as an operations engineer you have, and paths that that we found. This is not just my personal experience, this is based on research, we'll go into that a little bit later, that help you expand your skill set. A lot of this is based on what we see in the market, we being HashiCorp, what we see in interviews that we conduct with skills that we expect, skills that we test for, take home exams and everything. And well, to make this experience more hands-on, I like using this tool. It's called a Turing Pi. It's a carrier board that accepts compute modules, and each compute module is its own hardware server. Quick disclaimer, I backed their Kickstarter, I got one shipped. You could definitely consider me a fan because also at the previous version, from an engineering perspective, this is the coolest piece of hardware that you can get right now to increase your skills. Not only because it has 17 different LEDs that all light up when you plug it in. And if you look over there, the streaming PC with the blue white fan, this is a real shit. You know it runs faster because of that. LEDs define CPU clock time. So the real reason I like this board, 2 Ethernet ports, which means you can simulate chaos testing. aka you break the little nubbin on a network cable and then plug it in and pull it out right when you're hoping to do a big upload. Sounds fun? Is more fun when you can actually account for that in your application architecture. Simulating hardware outages is best done when you have a way to easily restore them and not in your data center. The other option, of course, for compute modules, Raspberry Pi compute modules, Jets and Nanos, if you're into that kind of architecture, I think they're working on their own. Where this is important is 4 is that magical number when you no longer will want to click things together in a UI. You'll want to codify this. And we talked a lot about this in the open space. As an infrastructure engineer, I can't say this in the open space, I can't say this in my session, if you're not codifying your stuff, I don't care if it's with Terraform or any of the other tools. If you're not codifying, you are wasting your time. And we don't have time. Other fun things that you can do here, SIM card slot, so you can take this anywhere, including in a waterproof box and drop it in a lake and see where that goes. Make the box float, probably, things like that. And of course, plug in lots and lots of USB devices, such as a YubiKey, HSM USB hardware security module. Jesus, some words are just too long to pronounce. So take the board, grab 4 compute modules if you can find them. If not, Jets Nanos, much easier. And what do you have? Your own server rack. Portable, smaller than my laptop, not very waterproof on its own. And the reason I know that is we had a baby girl 7 months ago who discovered that her water cup can be thrown across a table, which is where I was packing my stuff. Apologies for that. The hardware is very real, which I know everyone who's ever backed a hardware Kickstarter is like, but is this real? It has shipped. I've had it at home for months. It's great. It's not very waterproof. That's a hardware flaw on my side. That's not a hardware flaw on their side. As a training tool, well, depending on how you look at it, this cluster setup can either be a ton of at-home ops engineering problems or more or less ops engineering training, which can help you up-level your career. So let's have a look at a couple of paths. We'll start out with packaging. How do we run stuff in a cluster? And putting you on these paths, the easiest way to do this would be for me to give you 10 lines of code, 100 lines of code. Let's be realistic. Packaging is more of a 100-line problem, and send you on your way. That's not going to teach you how to advance your career. These scenarios, when you play them out with the knowledge you have, they will push you forward. Packaging is a huge part. No matter how long you've been in ops engineering, packaging has always been around. These days we call it a Docker image. It's really just a tar and some other meta information in there. But we've been doing this for a long time. Learning it on this low level means you're learning something that will still be applicable in 5 years when all you're doing is talking to Copilot and having it write your code for you. Because you still need to use the right words to push it forward. No matter if you're going with Debian-based systems, Red Hat-based systems. I know there's a lot of IBM folks here. You can't use Debian, of course. Windows, they're all great choices. And depending on the workload, you have to adopt, right? So, first scenario. We do this as part of one of our SRE interviews. It's one of the scenarios a candidate can choose. Build an image that is 99% ready. Well, the first thought would be like, why are we not building a fully baked image? Because that's less useful. 99% means I've got the right repositories installed, yum, apt-get repos, I guess Chocolati, if you're doing that on IIS, probably a bad choice. The right binaries, but no configuration for them. Because configuration is the last mile. It's the last % that you want to have just before you have your tooling start your server. You want to push that last bit in. Certificates, network information. Telling a database server, you are now running on this machine, and this machine we attached 4 terabytes of storage instead of 4 gigabytes, kind of differs. But if your machine image can deal with that, that's power. And so go deeper from there. Single target, super easy. Building a machine image that works in VirtualBox or on a Raspberry Pi, easy enough. How do you build that same image and provide value for your company when your CISO storms in and tells you, well, we're going to be multi-cloud now? Beautiful buzzword. I know our company uses it, lots of other companies do, but architecturally, you have to take a huge step back and think, what's the way of delivering that Red Hat Linux image that you have in the same way on 3 different clouds, maybe 4 local targets, without increasing your workload. Figuring this one out is one of those, shit, my mind is blown kind of principle, because you have to figure out different paths of architecting it. And it's going to be important when down the road we scale our cluster. And of course, everyone loves security. Security doesn't just haunt you for committing secrets to a Git repository. It also haunts you when your auditors don't actually know how trustworthy your infrastructure is. When you're building images, when you're deploying software, you need to be able to look at it and say, this software came from this branch, it was signed by these people have worked on it, we can verify there's no secrets in the source code, and we can trust it because we have this proof available. Scenario 3 is the hard mode of this one. Creating an image pipeline that runs a builder for an image, super easy. All the provenance for it, slightly harder. Well, let's go to something more fun. Infrastructure, to me, is always the traditionally more interesting part. We've got an image, we've got stuff pre-installed. So of course, for the first scenario, and I apologize for searing your eyes with the switch between black and white, we are going to figure out how to deal with that last 1%. We're going to use the industry standard Cloud Init for this. Every cloud provider out there supports this. This is magical. You pop in some YAML config, can even base64 encode it, which is not encryption, as much as Kubernetes wants you to think that. And you configure that last 1%. Where this is important is that you're taking that same image that you built in the previous path and now throwing in the configuration you need. Maybe it's a TLS certificate because your application needs mutual TLS, or your server. Maybe it's authorized SSH keys that you're retrieving from somewhere. Understanding how this path works pushes you forward. And this is not just understanding SysOps 101. This is very much understanding how do you make all those components go together in the same part, and more importantly, where do I retrieve those components from? Second scenario, well, I work with Terraform because I like how predictable it is. You can do the same thing with CloudFormation, ARM templates, Bicep, pretty much anything in this category. Figure out how to make your infrastructure predictable. Don't stop at, if you're in the Terraform world, well, I can do Terraform plan, and it will tell me what's going to happen, and then Terraform apply. That's easy mode. That's what we could have talked about in the open space. The hard mode is figuring out, how does this work when 2 people in your team work on this? How do you consume community modules and trust them? How do you consume work from your own team and trust it? How do you make sure the latest changes show up in your source code without breaking it? This is very much no longer, I'm going to click stuff to get in a UI problem. This is very much a problem of, let's think about architecture, and let's think about who has access to our code, and how do we make sure that gets treated with respect. Code that you don't treat with respect is code that will wake you up. It's very much like people. Thank you. In my intro, I like to usually say that I'm a failed stand-up comedian, but then I always get laughs from people, and I'm like, maybe I should have stuck with that. I mean, you get free drinks, still get a mic. It's a pretty good deal. Final scenario in this path, which is way more fun to think about. How do you alter your infrastructure based on external inputs? Quick show of hands, who was here for the open space on IAC Love and Hate? I definitely counted more people before that, that's fine. One of the things we talked about is retrieving stuff from the GitHub API. In the case of Terraform, there's a provider for that that can define other files. If you like over-engineering, and you're in operations, so of course you do, Terraform, I'll tell you something that I'm doing with Terraform that sounds really smart because it makes sense. I have the Terraform GitHub provider retrieve the commit hashes. I think GitHub calls them commit-ish, which is a very weird word, to say from the GitHub API for the GitHub actions I'm using. I then use the Terraform template file function to write GitHub Actions workflow files, so YAML files with those strings, to about 30 different repositories. So I use Terraform to commit files directly to my GitHub repositories through the GitHub API, and you might go like, well, that is batshit crazy. It is, but it alleviates the discussions I've had with our security team where they were telling me that my GitHub actions were not pinned to the correct checksum of a GitHub action. Usually, if you've seen GitHub actions, there's a uses command and something like uses /setup-terraform at v1. It's great. It's super user-friendly. Definitely more user-friendly than a 64-character string. Also very susceptible, because v1 today might not be what v1 is tomorrow. And if we're coming back to provenance and knowing what we can trust, having the exact checksum or commit tag is the only way forward. Is it over-engineered? Of course. That's the beauty of being in this industry, that we can spend time building stupid stuff like that. Could I use something else? Could I just write a Go CLI that does the same? Of course, I'm a Terraform person, so I use Terraform for that. Now comes the fun part. We've figured out everything that was easy so far, so we're going to do the slightly harder part. Security should be top of mind always. Realistically, for most engineers, I tried to plan security stuff in my sprints when I knew I was going to be on vacation. The beauty of being a team lead is knowing what your roadmap looks like and giving other engineers a chance to improve their skills. I'm now in marketing, which is why I can phrase it this way. Technically in marketing, which marketing people hate. So security is hard, and security is not something you should be doing alone. So let's do this step by step. For our first scenario, we're gonna deal with actually something we talked about in the open spaces. How can we bring secure data, certificates, so the private key parts of certificates, API tokens, usernames, service accounts, into our cluster or whatever we build in a predictable way without leaking that information? How do we store tokens that we generate at runtime? How do we make sure those can go in? Figuring this out is approximately 10,000 more that you could be earning a year. Unless you write a white paper about it and blog about it, then it's probably 15. The reason we all don't like figuring this out is because rotating passwords is hard, especially if you commit them, because that usually means rewriting Git history. Rotation flows, somebody usually comes into your team, they write a nice little markdown file, 500 lines, there's some screenshots, there's a ceremony attached to it, and you know this is going to suck because it's going to break exactly when you can't have it break, which is why security should actually be part one. Then, of course, if we're storing credentials, we need to encrypt data at rest. Do we have technology that supports that? Is our database suitable for that? I was at a conference last week where somebody came to me with a question, asked, well, we have a user database and we need to encrypt everything. All right, seems doable. We can't rely on what's built into the database because it's not safe enough for our system. All right, we kept going back and forth 5 minutes until we finally figured out a path that we would go with an approach of encrypting everything before it actually hits the database. And I got curious, like, why do you have to have everything encrypted by a system that is not the database? Well, the database could be breached. Fair. So you need to have a second layer. Just like we have 2FA, you have 2 levels of protection for your data. Eventually ask, what kind of work are you doing? You working for the government? It was a webcam site. So if you're a consumer of those in Germany, know that your data will be double encrypted in the future. It's great. Good security stands and falls with the user, always. How do you go about attaching an Active Directory, or more likely something like Okta or Auth0 to your users? How do you make sure the same user that can access your GitHub can access your Linux box without you having to go through the hassle of provisioning everyone? Fun fact, the GitHub public keys, the public key you have on GitHub can be retrieved through the GitHub provider with Terraform, which means you have a way of getting your public key into a server in an easy way, which means your organization has one less key that they need to maintain. And then, of course, the question is, if my key now shows up on every machine, how do we ensure that I can't access every machine? Because nobody should be able to. So figure out what policies you need to attach to. Infrastructure, packaging, security, all done. Networking, well, plugged in a cluster, plugged in a cable into the cluster and we're online. Networking is done, right? Like, can probably skip over that. This is more the problem of how does node 1 access something on node 2, but only if node 2 is healthy, and otherwise it should fall back to node 3. DNS health checks, application health checks, all falls on the networking. As developers, most of us are not interested in connecting on IP-based level. We want to have a predictable name. I prefer to connect to my database by just saying, you know, connect to a host called database or database.network and figure it out from there. How do we deal with that? What tooling allows us to build application resiliency? And resiliency is really the key feature. I think Matt mentioned this in his talk, saying that features are great, but actually having an application that's available and has an uptime is better. 100% agree. If you have a web shop and the add to wish list functionality doesn't work, nobody's going to give a shit. If you're not able to check out, that's a huge problem, because nobody being able to check out means the company is losing money, and everyone is laying people off, which is why you need to invest in security training for yourself. How do we bring monitoring into this? How do we make sure the right ports are opened at the right time in a predictable and scalable way without requiring human interaction? Self-healing systems sound super good on folders. They're incredibly hard to build. And so when you build observability into your tooling, you get a better understanding. You train yourself in new ways to think about your data. Not every application allows you to man in the middle your own network, and that's fine. Sometimes you have to observe it from the outside. The way you can go about this is really the best way to think about this is, if I don't need to be in the box and I can see enough from the outside through health endpoints and other things, then I've got a system I can trust, because sometimes you will not be able to access the box. That junior engineer that came in and threw away the .ssh directory, making it impossible for all your tooling to connect, the server itself is fine. It's still serving requests. As far as your client is concerned, there's no outage. As far as your operations team is concerned, there's a slight outage. The outage being, we now have a train that's on the track that we can no longer get into. And then I think finally the hardest part is orchestration. Getting applications to run reliably, predictably, preferably with as little resource overhead as possible, especially if we're talking about duplicating environments. Things can get really hard. If you have to duplicate dev test, acceptance, production even if you're scaling to different CPU and memory levels, the two most commonly used ways of saving money, you still want to have high utilization of a machine before you scale out. Doesn't matter if your applications are cron jobs or batch processes that do image parsing, or if you're running web servers that provide a guestbook. Figuring out what the path from a developer to an orchestrator is and building security and reliability into that is a huge, huge step forward for any engineer. This is not a thing that you can figure out in a day. This is a thing that you will iteratively improve upon. The first process will be, well, developer can push directly to the cluster. Second step will be developer pushes to a registry, and that registry we can then pull manually from. Then next step, developer pushes to a repository, checks get run. If those checks pass, we create a new commit tag. That triggers another action that goes into a registry. That registry gets auto-polled, and if there's a new version, we deploy a new workload. It gets complex. It also gets fun. Learn how to design a pipeline that takes into account all the previous things that we mentioned. And then, of course, mix it up. Always deploying the same workload is fun. If all your container images are sub 20 megs, you're not solving hard problems, because eventually somebody's going to go like, well, you know, we took ArcGIS, which is a geographic information system, we containerized it. Here's a 16 gig container image that we would like you to run on all servers. And you're looking at the memory and wondering like, well, but all my servers only have 10 gigs of storage. Doesn't work, obviously. But with that in mind, figure out what algorithms you have. Are you going to be bin packing? Are you so bringing as many binaries as possible onto a machine to get to that 80% utilization? Are you going for, oh, I only want 15% because everything can burst out all the time? How do you deal with failover? We joked about the Turing Pi and yanking out a network cable. How do you do this with a real cluster? And do it on your own cluster before you do it on the real cluster. Or don't, and you basically write your own DevOpsDays talk. 15 scenarios that all are much easier to say out loud than to solve. Literally all of them can be described in a single sentence. None of them can be solved in 100 sentences. And they are not random. I mentioned this earlier, these are all based on the research we do. We talk a lot with our users. Our team also specifically talks a lot with folks at conferences. We try to understand what are the problems that people actually face, and how do they face these problems, and how do they solve them. We solve some of this in our work, I'm sure you have too, but there's always something that you can be improving upon. And this is hard. This is very hard. This is not a single-person game, unlike Counter-Strike, which you can play all on your own. Infrastructure engineering is a team sport, as is security engineering and networking and everything else. In fact, we could actually say engineering is a team sport. None of us are ever going to be as smart as all of us. For DevOps Days, we like to bring devs and ops together. We've added security because that gave us bigger sponsoring budgets. It's great. But business is part of this. QA is part of this. We call ourselves engineers because we build. And some of the stuff we build is the most amazing stuff. It's artisanal. It's handcrafted. Our code is our baby. Does need diaper changes, but does need software maintenance. None of these technical skills are going to be worth it if you don't learn how to build them with your peers. The bonus here is, if you learn to build them with your peers, and I think coming back to what Thomas said in the keynote, learn in public and learn with each other. putting yourself out there, showing the humility that, hey, I don't actually understand how this works, will advance your career at a speed that no Udemy course will ever be able to. Some code I can share with you if you're curious where to get started for this. And if you're living somewhat in the HashiCorp ecosystem, Terraform Vault Console, head on over to github.com/workloads. My colleagues and I are building best practices implementation, and based on our coding guidelines, we'll say that Terraform is very subjective because my best practices might not be yours. Obviously, we use HashiCorp tooling for this, and pretty much all of our partners, instead of Chekhov, we use Sneak, but you still get the same concept. And you'll have some code to experiment with. GitHub issues are open, so if you run into any issues, definitely post them, so our GitHub Actions workflow can automatically thank you and close the ticket. Because honestly, it looks bad. If you go in there and you go like, well, this doesn't work, that gets people away. With that, thank you so much. You've been amazing. And go drink beer.